This is the second day of a 2-day lesson on solving absolute value equations and inequalities. And then I give them the function y equals 4 and y equals absolute value of x minus 3 and ask them how would they solve it on a coordinate plane, how would they use that to solve the three problems in this first part, A, B, and C. So the absolute value of x minus 3 is equal to 4. This is given a lot on the PARCC exam where they say if you set two functions equal, f of x equals g of x, solve for the solutions for x. And those would be the intersection point, the x-coordinate of the intersection point. So you can see from the graph that it's when x is equal to -1 and x is equal to 7. So that's going to be your two solutions, or x is equal to 7. In the second part, it's asking when is the absolute value of x minus 3 less than 4. Well, that's going to be between the x values of -1 and 7, but not including those. So open interval -1 to 7, open interval. And on the C, it's going to be when is the absolute value of x minus 3 greater than or equal to? Well, we already talked about it's equal to at -1 and 7, but greater than 7 and less than -1 on those x values is going to be where it's greater than or equal to 4. So you're going to have open interval -infinity to -1 closed interval, and then closed interval 7 to infinity. And then we move on to the second part of the activity, of the graphing activity, where it has, I asked them to write two compound inequalities for each absolute value inequality. And so if you look at absolute value of x plus 2 is less than or equal to 6, we've talked about that means it's 6 units from -2. So 2 plus 6 would be 8, and 2 minus 6 would be -4. Well, if you look at that on a number line, that means equal to would be at those numbers, closed circle, but then less than is going to be all those numbers in between. Well, if I write that as two inequalities for a compound inequality, that's going to be x is greater than or equal to -4, and it's going to be an and statement, x is less than or equal to 8. On the next one, it's going to be an or statement. It's going to be 5 units from 7 is what you look for the equal boundary, but even though it doesn't have an equal sign, we know there's going to be open circles there. So if you looked at the number line, it would be 7 plus 5 would be 12, 7 minus 5 would be 2, and then it would be open circles, but this time shaded to the outside of those so that when you take the absolute value, it's actually greater than 5. And so you would have the two inequalities would be x is less than 2, and this would be an or statement, x is greater than 12. And on the last one, you have 2 units from 8 is the first thing you start off with, which then you have to divide both of those answers by 3. So 2 units from 8, 8 plus 2 would be 10. But when you divide that by 3, that's going to be 10 thirds, or 3.3 1/3, or 3.3 repeating. And then 8 minus 2 is going to be 6. But then divided by 3, so 6 divided by 3, you're going to get 2. And so that's going to be closed circles at those points at 2, and then 3.3 repeating, or 3 1/3. And then, but greater than is going to be to the outside of those numbers. So two compound inequalities would be x is less than or equal to 2, or x is greater than or equal to 10 thirds.